Welcome back as we continue our interesting lesson in core mathematics. My name is Nanaya Wedu and you can call me Senana. Remember to like this video, share this video, and especially comment at the comment section if you find anything interesting or you want to ask a question. And don't forget to click on the notification bell and subscribe to my YouTube channel so that you can be the first to get all the videos when I put them on the channel. In our previous lesson, we've considered some real-life applications on angles. We've used questions to look at how some angles relate to our real lives. In today's lesson, we want to consider some special triangles, and for us to be able to define them, it will help us so that when we are looking at things like geometry and trigonometry, we'll be able to consider them well and have a good understanding of them. Now let's consider what special triangles are. So for special triangles, we are basically looking at triangles that have some role or impact in geometry and trigonometry as well as some real life applications. So we say that special triangles are the type of triangles that have immense role, right, or very good role or very crucial roles in geometry, trigonometry, and other applications, right? So for instance, as we see here, we can see a triangle A, B, and C and realize that the three sides here are said to be equal, right? So it means that the angle here, if it is 8 degrees, the angle here will be 8 degrees and the angle here will be 8 degrees, right? That is a special type of triangle. And then we can also have a triangle where you have one side to be at 90 degrees. That is also a special type of triangle. And then we have a triangle where we have two sides equal. So if the side is x degrees, right, it means that this side will also be what? X degrees. So now let's consider some of these special types of triangles. So first we have the equilateral triangle. And when we talk about an equilateral triangle, we are talking about triangles that have all its sides equal, right? So it has all its sides equal. And then since it has all its sides equal, it will have all its angles equal. So that implies that if this side is x degrees, this side will be x degrees, and this side will be x degrees. Now we know that the sum of angles in a triangle is 180 degrees. This is something that we must note at all times, right? That the sum of angles in a triangle is 180 degrees. So once a triangle is an equilateral triangle, it implies that x degrees plus x degrees plus x degrees should be equal to 180 degrees. In the case of this, where we represent all the three angles with x degrees. So we have 3x to be equal to 180. So we can divide both sides by 3, which is the coefficient of the x, and we find out that our x is equal to 60 degrees. So this implies that every side of an equilateral triangle is equal and every angle is at 60 degrees, irrespective of which triangle is given to. Once it's an equilateral triangle, every angle is at 60 degrees. Now let's consider that type of triangle, which is a right triangle. So once you have a side to be equal to 90 degrees in a triangle, then it's a right triangle. So one of the sides here is 90 degrees. Then we can see that that triangle is a right triangle. Now let's consider an isosceles triangle. So for isosceles triangle, two sides are equal, right? Two sides are equal. And this implies that two angles as well are equal. So it means that if this side is 50 degrees, then this side will also be what? 50 degrees. Let's consider them as maybe y and y, right? So it means that this side can be, let's say, x, and it will be 80 degrees, because when we sum them 50 plus 50 plus 80, we should get the sum to be 180 degrees. So once we have two sides, in this case, the angular B and the angular C to be 50 degrees or to be the same, right? Then we say that it is an isosceles triangle. So for isosceles triangle, two sides are equal and then two angles are equal. Now let's consider a scalene triangle. So scalene has all its three sides different. So all three sides are different, right? So for scaling, all three sides are different. And it also implies that all three angles are different, right? So a triangle can be scaling if we can have probably one side to be 70 degrees, another side to be 60 degrees, and another side to be 50 degrees. The sum of the three should add up to 180 degrees. This is different, this is different, this is different. We can call this side A, B, and C. And then we can say that algebraically, A plus B plus C should be equal to 180 degrees. So that is a scaling triangle. And then we also have an obtuse triangle. So for obtuse triangle, all we need to note is that one side is greater, right? It's greater than 90 degrees. So we can have a triangle where probably one side is 100 degrees and another side is basically, let's say, 45 degrees, and another side is 35 degrees. Once we have 100 degrees plus 45 degrees plus 35 degrees, giving us 180 degrees, then these three constitute three sides in a triangle, which is an obtuse triangle, because an obtuse triangle has one side greater than 90 degrees. Remember that we looked at obtuse angles and we mentioned that they are angles that are greater than 90 degrees but less than 180 degrees. And then we also have an acute triangle. So for acute triangles, you realize that all the three sides are less than 90 degrees. So we say that for acute triangles, all three sides are less than 90 degrees. Despite the fact that they are less than 90 degrees, when you sum them, you should be able to get 180 degrees for the sum of the interior angles of a triangle. So for instance, in the case of these, we can have 40 degrees plus 75 degrees plus 65 degrees, which gives us 180 degrees. So in this lesson, we basically considered the special types of triangles, and we mentioned that there are so many special types of triangles. You realize that as we move forward, you see this when we are looking at things in geometry, in trigonometry, and in real life application. Remember to share this video, like this video, and subscribe to my YouTube channel. See you in the next lesson.